the middle ordinate. We're going to be picking up where we left off last time. And so the middle ordinate is the topic for today. Now, let's back up a little bit so that you can have a good reference of what the middle ordinate is. If you remember, I gave you the sheet that looked just like this. And on that sheet, you can see here, there is something called the M, which is also referred to as the middle ordinate. Okay, now the middle ordinate is represented on your graph by the distance between the center line of the roadway and the point at which obstructions are no longer blocking any sight lines. Okay, so if I were to draw this on here, let's just say we had a huge curve. Okay, and it began here at PC and it ended here at P sub T. And I had a vehicle that was about right here. Okay. Now that vehicle would need to be able to see all types of obstruction that could be on that road. So that vehicle is maybe traveling on the center line of that road. All right. And we can go ahead and call it, let's just say it's a one-lane road. So therefore, if it's a one-lane road, then the center line would be right in the middle. So that vehicle is traveling right in the middle of that one-lane road. And the vehicle would definitely need to see anything that it is approaching. Because if it can see it, then it can make the necessary adjustments to either stop or move away or swerve away from it. But in the event that there is, let's just say, as I said before, a building here, maybe some trees and whatnot, maybe a signpost, who knows, anything. All of these objects here are blocking the sight line. And if you remember, the middle ordinate is basically the distance from the center line that is required to the nearest roadway object that can block the sight line. Alright, so the middle ordinate here needs to be actually represented right about here. Alright, because anything beyond that is basically going to block the sight line. Well, we don't want this to happen, especially if this road was being designed as such. So we actually need to do something. We need to figure out how far back we need to push these red objects. How far back do we need to push these objects so that the sight lines would not be interrupted. And when we figure that out, we'll determine what the middle ordinate should be. Alright, so let me go back and draw the exact same scenario. And again, we have a huge curve, the beginning of the curve, the end of the curve. We'll go ahead and assume that it's a one-lane road again, in one direction. Therefore, the center line is the middle of that road. And we can go ahead and assume that a vehicle is traveling right there. Now, if we know the vehicle's speed, then a different type of middle ordinate equation has to be used. See, in the beginning, the middle ordinate equation that you were given was this one right here. And that's just a general equation. It does not take into account anything for speed. Last class I talked about a modified version of that, and that modified version is as follows. The middle ordinate is equal to r sub I 1 minus cosine 28.65 divided by r sub I, and that also is multiplied by your stopping sight distance. Okay, so we have our new middle ordinate that accounts for speed. Okay, so if the speed is known, then we can design for a different way. Alright, well, how do we use this? Well, first of all, we have to know what our r is, our radius. Okay, and our radius is taken from the center line of the innermost curve. Alright, so the center line of the innermost curve in this instance is basically the center line of that one lane, because it's only one lane, it's only one curve. Okay, however, if I were to change this into being represented as many lanes, let's just say I had 1, 2, 3, 4 lanes there. If I were to change it to being represented as 4 lanes, then this n sub I, which is equal to Ri 1 minus cosine of 28.65 divided by r sub I times your stopping sight distance. That r sub I now needs to be measured from the center of the innermost curve. That is now r sub I. Okay. However, if for whatever reason you were given a radius that was referenced to the center line of the roadway, then that means you would have to actually subtract this distance, which in most cases would be 12 feet, and that distance, which again in most cases would be 6 feet, from that RCL, and then you'll be able to figure out what this new r sub I is. And once you figure out what that new r sub I is, you can plug it into this equation after determining what your stopping sight distance is based on the speed that was given to you. So let's go ahead and try an example.